All right, so here we go. So we are getting into forces in 2 dimension now. So you've already seen forces in 1 dimension. We talked about that with Newton's laws, Newton's first, second, third law, which you saw last year, and friction. So we've already covered that. Now we're going to look at this in 2 dimensions. I don't have my completed notes right now with this, so we'll see if I can fill in all the blanks. So, as with any vectors, forces must be resolved with consideration to their, what do you think?
Direction.
Magnitude and direction, yeah. So, magnitude and direction. You'll have to get used to the scratching on the board with this. If it doesn't make sense, just let me know. So we are going to need to not add forces like we did last year with, remember, F net, the sum of all the forces. Instead of just dealing with what's this force minus this force, if it's a winning or a losing force, now we actually have to take into account direction. So if I've got 2 students and they're pushing a crate, if one is pushing east and one is pushing now south, we want to know the resulting force. So I can no longer add these forces or subtract these forces. I need to deal with these as vectors. So I can draw these on here. So I've got 75 newtons going east, and I've got 48 newtons south, like this. This one's a pretty straightforward addition. You just go tip to tail. It's a 90-degree triangle. It's not going to be too bad. So if we draw this out, again, it doesn't matter if I draw it first the east and then the south, or if I do the south first and then the east, I'm going to end up with the same triangle. So I'll do this way. So we've got 48 on this side. I've got 75 on this side. From where I start to where I finish, this is going to be the resultant force, or F net, because we'll be dealing with F net mostly. And this is going to be the angle we solve for. Questions with that setup? Yeah?
So can we draw that triangle every time?
Yeah, other than if you're going to do the component method, you might just split it up before you make the triangle. So this method, whether you're using component or trig, it's going to get the same. Because they're already in components, I'm already combining them like this.
Last year we dealt with the same thing, but we didn't solve for F net, right? We only used the forces.
So
Because I remember we did the square, the box, and then we also did like direction and forces.
yeah.
But we never solved for the result.
So we did solve for the resultant. The only thing we did is we dealt with forces only left and right, or only forces up and down. So because now we're doing one of each, that's why we have to draw a triangle. But last year when we did F net, we would have some sort of box. We'd say here are forces that are acting on the box. Say this is 70, this is 60. I'm still figuring out the resultant. It's just now they're on the same line.
So it's 10 to the right, obviously.
Yeah.
Okay.
Yeah. So I'm still doing that. I just have now unbalanced forces in both directions, rather than just in one. Yes, Hashem?
Do you have any questions for the forces?
Yes, I will have questions with more than 2 forces.
How we solve it?
You'll find out once we get there. Yep.
So in this case, it's actually resulting force, but we solve the theta just because we want to solve the theta, or does it have to do with like, this is
So we can use Pythagoras to get F net, and that's what we'll do here. And then we'll use tan theta to get the angle, because in order to get a force, which is a vector, we'll need to also include direction.
So the theta gives us like how to indicate the direction.
Yeah, yeah. So whenever we're dealing with anything that's a vector, we need to know direction as well.
If we were to incorporate force of gravity into this
So in this one, because we're looking at this from a top-down view, we don't look at force of gravity, right? Because force of gravity would be either into the board or out of the board. So that is not going to account because we're just looking at the net force, and the force into the board, which is force of gravity, is counteracted by the normal force that's coming out. So they just cancel out.
in this unit, we're only going to deal with physics of gravity.
I won't say only, but the majority of it, yes. Yeah. All right, so let's now solve this. Again, like I do with most of these, I'm not actually going to get what the numbers are. That's irrelevant at this point. I'm just going to figure out the method of solving this. So I'm using Pythagoras. I can get F net. And I can use tan theta is the opposite, which is 75 over adjacent, 48. And from there, I can get what the angle is. And from this, once I get what the angle is, so this will be some number, what direction am I going to put with this? Is this north of west, east of north? What do you think, Fede?
East of south.
East of south. How did you get that?
Run down and then
Yeah, so you started down, you started at south, and then I moved east of south. So you need to know how to do those. Yeah, Danny?
would this also be north or east?
No, there is no north of east here. North of east would be some angle where I start at east and I move north of east, which that's nowhere in the triangle there. Yeah. Again, if I had set up my triangle differently, so suppose I did the east force first, I would get some triangle that looks like this. And again, I would solve for this triangle here, or this angle. This is going to give you the exact same answer, except instead of east of south, I'm going to get south of east. And when I get either of those, both of these add up to 90 degrees. So both would be considered correct. They're just looking at it from a different perspective. Any other questions with this one? Okay. So let's continue on. Are there more than two forces? Yeah. So here's the case that Hesham was asking about. If there is more than two forces. If there's more than two forces, you're not going to be able to solve this using the trig method. Because as you can see from this, you haven't learned how to solve a quadrilateral. So we're not going to do that. All we're going to do is we're going to break these up into components, and then it'll be easy. That's going to be the easy method to do this. So this you've seen, this is way back to the vectors. We're just going to break this up into components. So we'll use, let's see, for this one, this is going to be f1x. Since we're dealing with the adjacent sides, we're going to use cos. So 35 cos 20 to get the y component. We'll use sine. This time I'm actually going to calculate it. Is there any confusion where that came from? So basically I just took SOHCAHTOA, rearranged it already to get this. You use this so frequently that I just don't show the steps for it. That rounds up to 12. All right, so those are my two components. Then I'll do the same for the other two. So again, this one, this is f2x. we're just going to do the hypotenuse times cos 50. As I've said online when we did this, don't assume that x is always cosine and y is always sine. You cannot assume this because it all depends on how I give you the triangle. So never assume, always trying to actually figure this out. This is why I don't like actually calculating it because it takes too long. Okay, any questions with this so far? Would the second y be negative? Yes. Yeah. We're going to get to that. I keep forgetting I should probably restate your questions for those who are listening online, but I keep forgetting that. And it's always weird to have to repeat the questions. Some of them might actually listen to the questions. No. Because we got 3 forces. And trig only works if you've got triangles. This one you're going to have 4. So unless you want to do the trig, solve the resultant for these two, then use trig again with that resultant with the third one. How does a normal triangle have 3 sides, or 4 sides? Yeah.
I have a question.
Mm-hmm.
For the one of, I can't remember if it was a test or worksheet.
Yeah.
That I solved for things using, and I found out all of the x components and then the y components, and then for your negative and positive, I added or subtracted them.
Yeah.
And then the final answer, that was my result. Can I use that for the quadratic?
That's exactly what we're doing, yeah. Yeah, so the question was, you just found all the x components, you find all the y components, you combine them all, and then you get the resultant? Yes, that's exactly what we're doing, and that's your component method.
How would I solve for the angle if I have 4 different?
We'll get there. Yeah. The method is going to be the same. You're just basically making all the components, and then you just combine them all together, and then it's the same ending. So the last one here, this one's nice because this one is just simply already in its components. I've got f3x and f3y is simply 0. So that's pretty straightforward. So again, this is just component method, breaking everything up into components from the very beginning, and then we're going to combine those. Oh, wait a sec for those of you who are just writing this out. If you remember the component method, what would be the next step now that I've broken everything up into its x and y components?
We're going to combine the x's and y's. So for example, these x's, we'll use the 32.9 minus 34.5 because we want to use second one is going to the negative direction. Sorry, no, it's also positive. And then we're going to put all 3 x's are positive.
Mm-hmm.
And for the y, the second one will be negative because it's going down.
Yeah, so we're just going to combine all of them. So basically, we've already done example 1. Example 2 is saying we want to get the resultant. So this is what we're doing here. I'm taking all 3 forces and I'm adding all 3 forces together. Notice, if I take the x component of f1, which is this, and I take the x component of f3, which is this, and I take the x component of f2, notice I get the full x value for my resultant. Same thing if I take my y component of f1, which is this, and I subtract, because we're dealing with f2, the y component of this, it'll give me this y component of the resultant. So again, y component of this, y component of this plus the negative of that one gets me down here, which is the y component of my resultant. So that's why this trig method works, the component method works, because I'm just taking all of them and combining them together.
Mr. Brandon, you explaining that made everything clear.
Really? Because I explained that online, but somehow just might not have sunk in. It's okay. It happens.
I don't think anyone pays attention online, Mr. Brandon.
That's
Honestly,
based on what I see on some of the tests, I can attest to that, yeah. Given that I have people who give answers to solutions that are nowhere near how I did it during class time. So they're either learning it from somewhere else or they're taking the answer from somewhere else. So let's go into this. So what we want here is we want the sum of the forces in the x direction. So fx1 plus fx2 plus fx3, and this will give us our resultant. So this one I will actually do. 9. I got 126.8. Is that what you got? Yeah, the units for forces are newtons. So notice with this, the y component is negative. And you can see that from my resultant here. The y should be going down. So this makes sense. Yes, Hashim?
I have a question about the symbol here.
Mm-hmm.
We have 4 at the top and 2 at the bottom. Does that mean you're adding 4 and 2?
4 at the top and 4 on the bottom? What do you mean?
Above the sign and the 2 below. Sometimes like the sign is...
always numbers written on top of the
For this one?
Yes.
What does it mean if you put numbers on the top and the bottom? So that indicates, well, it's not something you need to know for this course, but essentially you'll have, so like you'd say here, I equals 1, which tells you what your initial value is going to be of this, with the I value here. So that means you start with I equals 1 down here, and it goes till 3. So that just means I is going to equal 1 all the way up to 3. So I'd have fx1, 2, 3. But again, that's more if you're dealing with series equations, which you don't in this course, and I don't think you do in calculus, but I'm not sure.
When we answer that question on the top part, we have to draw this street
So you're asking if you're solving a question like this, do you have to draw this out? No, you don't have to. If you just did this and broke it up into components and showed me that, and then showed me this step, and then drew the final triangle, that's fine. This is more just to show you if you add all the x's, it equals the total x. If you add all the y's, it gives you the total y. That's essentially where that's from. From here, we can make our resultant triangle. Because we know what this value is, we know the x value here, and we know now the y value here. So I know this is 126.8, and I know this is 16.9. So from that, I can get the resultant. And from that, I can get what is this theta in here. Again, I picked the theta from where the resultant starts, not where it finishes. So I'll draw this a little bit over here so you can see this clearly. I'm not going to do this example. Don't worry about this one. So this is what we got. We got 126.8, and we got 16.9. So notice the negative with this just told us direction of the y, but when I put this into my triangle, I keep it as positive. So keep it like that. I'll get to your questions in just a sec. I'm almost at the end of the question here. So from this, we've already seen how to get this resultant. So FR squared will be these two sides squared. And then to get the theta, use tangent. So opposite, which is 16.9. And what did I want to get? Oh yeah, so theta is some number. And then in this case, what would be the direction? Celine? I'll get to your question in a sec. First, I want to figure out, is this going to be north of west, west of south of east? Yeah, how'd you get that?
Common sense, yeah.
Common sense? That doesn't always work. Yeah. So you're going east, and then you went south of east. Which I'm glad it's common sense for you, but for most people it's not common sense. Some people have to think about that. You can also think of it as you're dealing with east, and then you go south from east. So that might be another way to do that. Just a sec. So we said south of east. So that would be your answer. You'd get some number for your force resultant. You'd get your number for the angle. Yes, now you can ask your question.
Can you go left? How is theta that and not from the F1 to the 16.9 angle?
Which angle? This one?
Yes, how is that not the angle?
Because this is the angle that F1 is going at, not my resultant. So I want to look at the resultant, which is this line here. So you're comparing the horizontal to F1, which is just the original angle, which we're actually told here is 20. So we have that one already.
So the F net angle wouldn't be 20 plus the theta? Plus theta?
No, the angle is not going to be the 20 plus the theta because we want the resultant in reference to either north, east, south, or west.
So the horizontal is the greater.
Yeah. So if I compare this one with this one, I'm saying the force resultant is whatever 36 degrees south of 20 degrees north of east. Because that would be what this line is. I'd much rather compare it to the east. Yeah. Betty?
Shouldn't the angle equal both angles to that equal 90?
No, because there's nothing that says that these two angles need to add up to 90. Because they're not perpendicular.
Would you give us a question where if you give us the acceleration and the mass and then you also solve for the forces, two different forces that solve for this?
Yeah, so I can give you something like this where I give you the mass of the object and say what's the acceleration. So you'd solve for F net, and then from the F net equaling ma, you could solve for the acceleration.
Two different forces and then you like break it down.
Mm-hmm. Yeah. It's the same as what am I thinking of? The same as in vectors. Remember with vectors we had word problems where they gave you velocities and you wanted distance, or they gave you change in velocity and at time, and you solve for acceleration. So there could be some variation on that. So I got 12 minus 34.5, and I don't know how I got 16.9 from that, but apparently I did. Oh, because I subtracted the x value, that's why. Yeah, you're right, I'm wrong. This should be negative 22.5. And that just changes this. Yep, thank you.
In case, like, if I wanted to draw triangles in a different way where the x and then the y is not it, what would the direction of my table?
You mean if you did x first and then...
The y is on this side.
Oh, I get what you're saying. Yeah, so if I did the y first, so I did first this, and then this, so then you would solve for this angle in here, and this would be, so you go south, and then you went east of south.
And is there, like, can we do it in a way where I don't use the Does that work?
No, because those, the way that you have that drawn, you're drawn from tail to tail, and you need to do a tip to tail addition. Yeah. Yeah, but that's a very common mistake. So the question with that is, can I draw it like this and get this resultant? So this doesn't work because here you've got tail to tail. So if you're adding this vector plus this vector, you'd need to go the tip of this one to the tail of this one. Essentially what you've drawn here, Lila, is you've drawn what is this vector plus this vector. Because these are the two that are tip to tail. Yeah. So you're saying with subtracting, like, can you just do the components? Essentially, that's the same, but it's just confusing when you draw it like that, as to drawing tail to tail, because you don't know which one you were subtracting. So you don't know the direction of the resultant. So instead of just going tail to tail and then not knowing, do I go like this or do I go like this, you just flip that second arrow so that you can figure out easier what the direction is. Any other questions with this? Sorry, you're talking about this angle compared to this one? Yeah, so these are going to be the, they're going to both add up to 90 degrees.
Yeah, so like if I drew this diagram and then I do the other diagram and make sure that I drew the correct diagram, both of them have to have the same direction.
Yeah, so you could do that if you wanted. So if you drew it like this, solved it, and then you wanted to figure out what the other one is and just make sure it's correct, yeah. But the only problem with that is if you're still using the same sides, you'll get 90 minus this no matter what for this one. So even if I got these numbers wrong and said it's 10 and 20, and then I flip them and solve for this, I would still get 90 minus what that angle is. So that method won't really help you in solving what it should be. Yeah. Yeah. Any other questions with this? Okay. I can't remember if there's more to this notes. Nope, there's not. Okay, so that's it for forces in 2 dimensions. You've still got 45 minutes left in class here to work on the practice problems, and I will print off these notes now so that you will have those.